This is the problem. DC series configuration is given here. The potential here is 10 volt, 4.7 kilo ohm resistor value here, and this diode is silicon diode, and this resistance value is 2.2 kilo ohm, and this is across this resistance drop is V2, across this resistance drop is V1, and this is the output voltage, and this is the potential drop here is minus 5 volt. Now we have to find out the value of I, the current value, this I value, V1, V2 and V0. So for that we assume that diodes are ideal and in forward bias directions, so we can make again draw this diagram. So this is the resistance 4.7 kilo ohm, and this diode is short, is a closed switch, and this resistance will be 2.2 kilo ohm, and this is the VO is positive, and this is the potential drop here is 10 volt, so this will be positive, and here is a ground negative 10 volt even. Similarly, the potential drop here is minus 5 volt, so we can give the polarity minus and plus, ground will be 5 volt, E2 will be, we can write here E2 is equal to 5 volt. Now we can apply here the KVL to the loop, the KVL to the loop, this complete loop we can apply the KVL. So applying KVL, so here the polarity from negative to positive, so it will goes to plus 10, then positive to negative 4.7 kilo ohm into I, this is I, so we can write here minus 4.7 into 10 raised to 3 into I, and again polarity will be positive to negative is a fall, so minus 2.2 into 10 raised to 3 into I, and here polarity will be change from negative to positive in this potential, so the rise in voltage we can write here is plus 5, plus 5, and that is equal to 0. Now we have to calculate this equation, so we will find out I value will be 2.17 milliampere. So this is the value of I. Similarly we can find out V1 is equal to I into R1, and R1 value is 4.7 kilo ohm, this is R1, this is R2, so we can find out here 2.17 into 4.17 into 10 raised to minus 3 into 4.7 into 10 raised to 3, so this value will give the voltage is equal to V1 is equal to 10.2 voltage. So this is the one answer. Again we have to find out the V2 value, so V2 value will be I into R2, so I value we know that 2.17 into 10 raised to minus 3 into R2 value is 2.2 kilo ohm, so this value will be V2, that is equal to 4.7 volt, and then we can find out VO, and VO is the value voltage between V2 and E2, so V2, here is a V2 and E2, difference between V2 and E2, so this voltage will be difference between V2 and E2, so we can find out here V2 minus E2, that is equal to 4.7 minus 5, so VO is equal to minus zero point 0.2 volt. So this is the answer of this question. So here we can find out, here we can write here VO is equal to V2 minus E2, and that is equal to 4.7 minus 5, that is equal to 0.2 volt minus, that is equal to VO. Thank you.